This is going to be the Unit 8 test review for Day 1 and Day 2 for 8th grade. Taking a look at number 1, it says, which of the following has a value between 22.3 and 23.8? Best way to go about this is to just take each one of these numbers and put them in the calculator. So I'm going to do the square root of 490, and I get, I'm going to do 2 decimals on each one of these. This comes out to 22.135, so I'm going to round it to 1/4. Square root of 510, plug that in, and I get 23.2, and again, I'm going to have to round a little bit, so I'm going to round it to 4. Square root of 570 is going to be 23.87, and then the square root of 590 is going to be 24.2, and I'm going to have to round up to 29. Now, I'm trying to figure out which one of those is between these. I'm going to tack on an extra 0 on each of these so it's a little bit easier to see. So now I can just treat this like money. So $22.30 between $22.30 and $23.80. Well, that $22.14 is too small. So that's too small. That one's out. $23.24, that looks pretty darn good. So let's check out the other ones just in case. So $23.87, that is too high. $24.29, also too high. So we know that it is going to be B. On number 2, right triangle ABC is shown below. Which of the following is the best approximation of the length of the hypotenuse? Well, the hypotenuse is the same thing as side C. And you've got to know that. Here's our right angle right here, so I know the opposite side is side C, or our hypotenuse. So they've already done all the work for me. They've got the square root of 32 there. So I'm going to type in my calculator, square root of 32, and I get a value of 5 point, I'm going to do 2 decimals again, 6, and this rounds up just a little bit, 6. Well, the closest one on here is going to be that 5.7. So not too much work to actually be done on that one. Taking a look at the next one. Number 3, a model of the Pythagorean theorem is shown below. Based on the information in the model, which equation represents the Pythagorean theorem? So here's what I'm going to do. I'm going to set it up just like I always would. I'm going to highlight side A because it's my smallest side. So here's A. Here's side B. And side C, again, always opposite the right angle. So here's my side C. So if I was filling this out, I would do A squared plus B squared equals C squared. Now, I'm going to use the values that they've already given me. For A, because each one of these has that little square mark on it already, these values have already been squared. So I'm going to plug them in exactly as I see them. So A squared is 9. There's nothing extra to do with it. I don't have to square it or anything else. B squared is 16. It has already been squared. And C squared is going to be 25 because there's nothing extra to do with it. So now I'm just going to kind of take a look through my answers. Well, the only one, actually, there's one that matches exactly what I've got right here. Well, almost exactly. They've got the numbers a little bit backwards. They've got the 16 plus 9 instead of 9 plus 16, which is completely fine. Now, taking a look through the other answers, B, I want to mention they are trying to trick you because they were going to square it, as I imagine a lot of you guys might want to try to do as well. I do want to take a look at some of these other answer choices just to be on the safe side. So 5 squared would be 25. Actually, I'm going to just rewrite this one off to the side. 25 plus 3 squared is 9 equals 4 squared, which is 16. Well, again, that doesn't match what we have written up there. 25 is our side C, and that one should be by itself. So C is definitely out. And I meant to mark out B earlier. And then D, they've got 4 squared, which is 16. Plus 3 squared, which is 9, equals 5 squared, which is 25. Taking a look at what I've got up there, that actually works. A and D, I've already double-checked the test. They don't have it set up quite like this, but A and D are actually both acceptable answers. So make sure that you know that you're checking every single one of these just in case. But like I said, the test doesn't have it quite like this. I'm going to go ahead and let you know I'm pretty sure the test is set up more like this, where you're going to have to double check your answers just to be on the safe side. So just be careful on that. If you've got questions, make sure you're asking. Take a look at number 4. On some days, Jaden travels from home directly to his work. On other days, Jaden visits with his friend on his way to work. Approximately how much farther would Jaden travel by walking from his home to his friend's house and then from his friend's house to work than he would by walking from his home directly to work? Here's the important part. How much farther? Because they're asking how much farther, we are going to have to do subtraction. In fact, I'm going to label this part subtraction. So they've already given us some values here. And I do see a right angle right here, which means that this is going to be side C. So let's take the question one part at a time. So if we're trying to figure out how much farther he's going to walk by, so I'm going to highlight this as I read it so you can see. By, where'd it go? Walking from his home, so from his home to his friend's house, so going this way, and then from his friend's house to work. So that's the full distance that he's traveling. So what I'm going to do, and again, I'm going to kind of mark these side A, side B. So here's side A, here's side B. If he's going from home to his friend's house and then to work, he's traveling that 320 yards, and he's also traveling that 150 yards. So we are going to have to add these and figure out how far he is walking in total. So he's walking a total of 470 yards. Now we want to know how much distance he would save if he walks straight from home to work instead. So we're going to have to solve for that side C first. So I'm going to plug things into the Pythagorean theorem. I've got a squared plus my b squared equals c squared. I'm going to plug in my values. A squared, I don't have a squared, but I have 150 for a, so I'm going to have to square that one. B is 320 yards, so I'm going to have to square that, and I'm going to have to solve for side C. So 150 squared is a lot, so that's going to be 22500. 320 squared, if I can type this in properly, is also a lot. So 102,400. And that gives us our side C. So now I have to add these two values. So I'm going to add my 22,500 to that other big honking number, and I get 124,900, and that is my C squared. So I still have to take the square root of that answer. And I get approximately 353, and we'll call it 0.4 for right now. And that is side C. So he would walk a total of 470 by going from home to his friend's house and then to work. But if he takes this direct path to work, that 353, and I'm going to drop that. Well, I'm going to keep the 0.4, just since I've already got it written. So I'm going to add a decimal here. I'm going to subtract and find the difference to see how much time or how much distance he would save. So distance saved would be 116.6 yards. So this is not exactly a difficult problem, but there are a lot of steps to it. Make sure that you know a couple of things. Most of you guys are going to recognize that you're going to be solving for the Pythagorean theorem. I guarantee that will be an answer on your test. You've got to know that you're finding the difference between the direct path and the path that takes him to his friend's house. So nothing hard mathematically, just understanding what the problem is looking for. That's the hard part. Number 5 is just going to be a lot of work to show. It says which triangle is a right triangle. So here's what I'm going to do. I'm going to go through, and I'm going to do this all at the same time. I'm going to go mark my A's, my B's, and my C's. So those are my A's. There's B. Fortunately, these are all facing the same direction. And then here's my C. So what I'm going to do is I'm going to plug each one of these into the Pythagorean theorem. The A squared plus B squared equals C squared. And if I get the same value on both sides, then I know I have a right triangle. First thing I'm going to do is I'm going to go through and set up each one of these in the Pythagorean theorem. I'm only going to have the Pythagorean theorem written once here, though. So for A, I would have 3 squared plus the 4.5 squared equals 6 squared. On B, I would have the 7.5 squared plus the 9 squared equals the 16.5 squared. On C, 5 squared plus 8.5 squared and the 10 squared. And then on D, 9 squared plus the 40 squared and the 41 squared. So now all I'm going to do is I'm going to go through and get a value for each one of these sections, and I'll see if my numbers match. So looking back at A, if I plug in that section, I get 29.25, and for 6 squared I get 36. So this one is out because these sides do not match. On B, if I plug in the 7.5 squared and all of that, I get 137.25. For the 16.5 squared, I get 272.25. So that also does not match. On C, when I plug in the 5 squared, etc., I get 97.25. And on 10 squared, I get 100. So those also don't match. So I'm really counting on D to match. So when I plug in D, I get 1681 on the left, and I get 1681 on the right. So those match. My answer is going to be D. If you have questions on this section, please make sure you guys are coming by to ask. An apartment complex stretched a string of decorative floats diagonally across the pool as shown below. What is the length of the string of floats, excuse me. So here's what I'm going to do on this one. I see a nice, good old-fashioned right triangle. If you're not sure, this right here is the right angle, and opposite of the right angle is going to be our side C. These other sides I'm going to go ahead and get labeled. This is going to be A, and you can see from the other side that A is 20, and B is right here, and B is going to be 35. So it says, what is the length of the string of floats? So we are talking about side C. So I'm going to label this C. Now I'm going to use my formula, the A squared plus B squared equals C squared. And we already know the value of A, so it's 20 squared plus my 35, that's where that B is, squared, equals our C squared. So here's what I'm going to do. I'm going to plug each one of these in. 20 squared is going to be 400. And for 35 squared is going to be 1225. That equals our C squared. So now when I add these two together, I get 1625, and that is my C squared. So now I've got to take the square root of 1625 to have just C by itself. So when I do the square root of 1625, I get 40.3 and some other decimals, but I'm just going to do that for right now. So 40.3 is what I'm looking for. B is the closest answer on that one. Taking a look at number 7. So the triangle ABC is graphed on the coordinate grid below. What is the length of side AB? So side AB is right there, and that is my hypotenuse because it's opposite of the right angle. Here's my side A, which is 1, 2, 3 across. Here's my side B, which is 1, 2, 3, 4, 5, 6, 7 across. So now I've got my lengths. So same thing as before. A squared plus B squared equals my C squared. A we just said is 3, so 3 squared. B squared is going to be 7 squared, where B came from, and again C squared. 3 squared is 9, 7 squared is 49. Now I'm going to add both of these, and I get 58. And so final step is going to be take the square root of 58 to get C. When I take the square root, I get 7.6 is about what C is. So now I'm going to look over here and I get 7.62, which is exactly what I'm looking for. This is going to be for section with day 2. So number 8 says triangle ABC is graphed on the coordinate plane below. Which of the following lengths approximates the distance between point A and point B? So here's point A to point B, and this is side C. So now I'm going to take a look at these from here to here. This looks like my shorter side. I'm not really sure, but I'm going to call that side A, which is 1, 2, 3, 4, 5, 6, 7, 8 in length. And here's my side B, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 in length. So B is 9. And just because I'm trying to find the lengths right there, I'm going to do the same thing as before. A squared plus B squared equals C squared. A is 8, so I'm going to have 8 squared plus 9 squared, that's what B came from, and that will be my C squared. 8 squared is 64. 9 squared is 81. Again, now I'm going to have to add these two right here. When I add those, I get 145. And that's my C squared. So I'll take the square root of 145 to get C. When I do that, I get 12.04 is C. So our answer is going to be A on that one. Take a look at number 9. It says the width of a rectangle is 6 feet and the diagonal length of the rectangle is 10 feet. What is the measurement of the length of the triangle? So whenever they don't give you a picture, draw a picture. They just told me that the width is 6 feet and the diagonal length from one corner to the other is 10 feet. Being a rectangle, I know this is my right angle, and I know that this is going to actually be my side C. And because this is my width, this will be side A. Leaving it with side B over here on this side. So just like before, A squared plus B squared equals C squared. From here, you just start plugging in your numbers. So I have 6 squared plus B squared, we don't know yet, equals our 10 squared. So I'm going to keep working out what I've got here so far. 6 squared is going to be 36 plus B squared we do not have, so I'm going to keep calling it B squared. And then 10 squared is 100. Now, for this section right here, there's nothing I can do. I cannot add those. So if I cannot add what I have right next to each other, I'm now going to subtract. I take the 100 and I'm going to subtract 36. And that will leave me with B squared. 100 minus 36 is 64. Again, leaving me with B squared. So now at this point, I'm going to take the square root of 64 to be left with just B. And square root of 64 is just 8. So no multiple choice on this one, but I do know that side B is going to be 8. And it makes sense too, because 8 is going to be less than my side C, which sounds just about right. On to the next page, number 10, says how many degrees is angle C? Well, here's what I need you guys to remember on this one. Whenever we're talking about the interior angles, or the inside of a triangle, the whole inside of the triangle adds up to 180. But if I talk about angle C, is the same thing as these two added together. So if I add that 30 and that 85, add those, so 30 plus 85 gives me 115. So C is 115. That's the easiest way to get that one. There are other ways. If you want to know, please ask. Number 11, in the diagram, lines L and M are parallel. Line N is a transversal that creates 8 angles within the parallel lines. So here are my parallel lines. I'm going to mark those in blue. And this one going diagonally across, that is my transversal. So this is based on the information in the diagram. Which of the following statements is true? Before I even bother looking at the multiple choice, here's what I know for sure. I know that all of my vertical angles that are diagonal from each other are the same. So 1, 4, 5, and 8 are all going to be the same angle. On the other side, I know that 2 and 3 are going to be the same angle, and 6 and 7 are going to be the same angle. So now I'm going to take a look at these. Says on A, says angle 1 and 5 are the same. So looking at right here, 1 and 5 are the same. They're both green, so I know they're the same angle. And it says 5 and 7 are supplementary. Well, supplementary, whenever we're talking about angles, supplementary means that they add up to 180 degrees. So if I were to take a look at this, I could talk about 5 and 7. Both of these angles together make a flat line adding up to 180 degrees. That looks really good. On B, it says angle 2 and 6 are the same. Well, angle 2 and 6, they're both red, so yes, they are the same. And it says 6 and 7 are supplementary. Well, angles 6 and 7, they are not going to be supplementary. The two of those together do not make a flat line. So B is out. On C, it says 4 and 8 and 2 and 5 are the same. So let's look at 4 and 8. 4 and 8 are both green, so that's good. In fact, I'm going to underline these in green. 4 and 8 are green. And then 2 and 5. Well, 2 is red and 5 is green. In fact, that's probably how I should do this. So I've got those are both green. 2 was red, 5 was green. So this one is now out. On D, it says 3 and 7 are the same. Angle 3 is red. Meant to circle that in red. Angle 7 is red. Angle 1 is green. And angle 6 is red. So if that one didn't work out, it's supposed to be red. So D is also out. So our answer is definitely going to be A. Number 12. So triangles GHI and triangles JKL are shown below. Based on the given information in the triangles, determine if triangle GHI is similar to triangle JKL. Well, before I bother going to look at my answer choices, here's what I know about triangles. I know that the whole inside is going to add up to 180 degrees. That's 180. I want to find out this angle right here first. So if I take my 72 and I take the 35, 72 plus 35 gives me 107. So to find out that other angle, I'm going to do 180 minus that 107. And I get 73 degrees. So I know that this right here is 73 degrees. Taking a look at this other one, I have 72 and 35 again. I have both of the same angle, which means that they would add up to 107. And that means 180 minus 107 would again be 73. Both of these triangles have all three of the angles are identical. And if all three of the angles are the same, I know that they are going to be similar triangles. So looking through my answers, A says the triangles are not similar. That one's out. B says they are similar. Okay, I'm not going to read into why yet. C says they are similar. And D says they are not similar. Well, I do know that they're similar, so I've got rid of 2 right now. So now I got to finish reading. So on B, it says triangles GHI and JKL are similar because if 2 corresponding angle pairs are congruent, the third pair is also congruent. That's pretty much exactly what we just figured out. I'm going to read through C now. Triangles GHI and JKL are similar because their interior angles add up to 180 degrees. That is not a false statement, but all triangles add up to 180 degrees on the inside. And because of that, not all triangles are going to be similar. So C is out. Our answer will be B. Taking a look at number 13. This one's way more complicated looking than it really is. In each diagram, line A is parallel to line B, and line C intersects line A and B. Based on the given diagrams, which statement about the value of x in the diagram below is true? You can use these diagrams to help you out if you'd like, but at this point, we ought to be pretty familiar with this. All of our vertical angles that are directly across from each other are the same, meaning all of these x's are 117. So now I'm going to start reading through my answer choices. A, the value of each x is 117. That sounds good so far, because all of the labeled angles are congruent. That sounds really good already. B, The value of each x is 63. Well, no, we just figured that out that they're all 117. So it doesn't even matter what the rest of that says. C, the value of each x is 130 degrees. Again, we just figured that out. That's not at all true. And D, the value of each x cannot be determined from the given pattern. Well, we just figured it out, so that is also not true. So our answer is definitely going to be A. Final problem on the review says which number line shows a point that best represents the value of 200 square root of 250. So if they give you something like that, figure out what the value is, plug it into the calculator. And that comes out to about 15.8, so a little over halfway past 15. So I'm going to take a look at each one of these. Here's the halfway point. That's a little bit after. That looks pretty good to me. Here's the halfway point. That's a little bit before. That one's not going to work. That one isn't even past 15. Our number needs to be somewhere in here. So this one's out. And 16, again, our number is supposed to be somewhere in here. That one's too far past. So our answer is definitely going to be A. Guys, if you have any other questions, please make sure you ask because I want to help you out. Come to tutorials if you're not sure.